Welcome to our first section, 3.1. I've actually done this a couple times right now. You might have seen my other lousy videos. So I'm excited to finally, well, in fact you have on the syllabus. I'm just not going to change that one because you have it. But welcome to our class. What we're going to do now, what you're going to see from a lot of our sections, is going to be me talking through the slides that we have on our MyMathLab website. This is the same thing that I would do in class, except one set of slides might take the whole class period because you'd be able to ask questions and I'd be able to answer them. And I'd also go through and give some other examples just on the board based on handouts that we'd have in class and stuff like that. In this case, in this class, you'll be working on the homework and you can send questions to me via MyMathLab. So those are the different setups that we have for this portion of the class. Of course, when we get to Wallops, we'll be able to do lots of stuff in person. Okay, so section 3.1, what is a function? Well, before we even talk about what's a function, we have to talk about some other things. First thing is something that comes before a function. You might have forgotten this, but it's called a relation. And a relation is just a correspondence between any two sets. So in math terms, we might talk about what is a set. Well, that's just an x and a y. You are probably familiar with x's and y's all the time, and in fact, here you can see we have y equals 3x minus 1. That's an equation. You're probably familiar with that, and you may know that if you plug in 1 for x in this equation, then 3 times 1 minus 1, where 3 minus 1 equals 2. That is a relation. It's saying that 1 is related to 2 via this equation, which also is a function, but we'll get to that later. And overall, we get this line that maps out an infinite number of these relations. Another relation is that x equals 0 is related to negative 1 because of this relationship. That would be if you plug in the x as 0, you get negative 1 as your answer. So that's just one way that we have a relation, and it's a mathy type way of having a relation. Another way that we have a relation, which remember here's our definition, is just looking at any two sets. We can define them in any way. So here's just 5 numbers for x, 3, 1, 4, 7, and 9. Y can also just be defined as 5 different numbers, and a really easy relation is just to say that, oh, well, the first guy in x is related to the first guy in y, and so on. So we just say, here's this relation. And we usually don't write them like this. We're used to seeing them as ordered pairs that look like this. So we see that there's 3 is related to 2 because they're both the first guys in their set, and we have this set 3 comma 2, or 1 comma negative 1, 4 comma 5, and so on. So these are 2 mathy type examples, and you might have some examples in your homework where it's talking about here's a name with a pet or something like that. All right, so we're just looking at these relations. We're saying, yeah, great, that's a relation. So does this actually happen in the real world? Well, yes, it does. We talk about this stuff all the time. We just don't talk about it in math terms, but we relate things to each other. So in the case here, I have the map of the United States with the number of electoral college votes that each state has. So the most common way of doing this is saying that our capital X would be the name of a state. So for example, for Pennsylvania, right there, for Pennsylvania, we would say, oh, look it, I have 20 electoral college votes. Great. Or if I said, how many electoral college votes does Minnesota have? So Minnesota is my lowercase x, right? Well, I know that Minnesota is this shape, and I say the answer is 10. Minnesota has 10 electoral college votes, right? And I could do this for any one of the states. I'd have an x and a y. Now, another way I could do this is I could say, instead, my x is the number of electoral college votes each state has. This might be the way that the candidates, Mitt Romney and Barack Obama, look at this when they try to prepare for the election. They say, okay, which states have 20 electoral college votes? Well, the answer here would be 2 of them, Pennsylvania and Illinois. I don't know if you knew that was Illinois, but there it is. There's Illinois. So they both have 20. So now we're saying our x is the number 20 and our y is the name of the state. That is another way to look at things that can be helpful in the real world, but we're going to talk about relations first. Now we're going to talk about functions coming up. So remember that example. Another type of function, another type of relation that we often see and talk about is with regards to stocks. Now look at right here. This is a stock chart for 6 months. It was July 20th to January 19th. I mean, this is, some sort of, it was a while ago. That's okay though, because we're just looking and saying that, look, on the bottom we have dates, and on the side we have dollar amounts. So we could look at this and say, about Halloween, the value of Google was almost $600 or $595 or something like that. That's what it would tell us. It would say the X component is the date and the time actually in that day, and the Y component, and that in this case is going to be the end of day value of the stock, and the Y component is the dollar value. That's a relation. Another one that's maybe more important to us here at home. This past September, we had a really big flood. You might remember that. Maybe you lived close to it. This is something that the USGS, the United States Geological Survey, they keep track of many creeks and streams and rivers across the whole country, not just Pennsylvania, by having these readers, these sensors that pick up values every 15 minutes. So here is this thing. You can go online and find this data real time. So they have Yellow Breeches Creek near Camp Hill, Pennsylvania. So you can see right here, it's measuring the Y value, the height of the creek, versus time, the X values. That's the relation. If you say, if I could go in there, I could say, okay, what was the height of Yellow Breeches Creek with my X value being midnight between September 6th and September 7th? I would go right there and I'd say, oh wow, it was about at 6 feet. Now, normally that wouldn't be that much cause for concern because that's below flood stage, which is this red line. However, it was raining a lot then, and it had been raining a lot, and we knew we could see this trend line. This is going to go forward. This is sort of a sneak peek, but we're saying, wow, this we've had a line there. It almost looks like it's going straight up. We know it's still raining, and you probably could have predicted at that point that at some point the next day, and it was very early the next day, we had gone above flood stage, which isn't that good. So we could see all this times we're at flood stage. We were flooding between on the 7th and the 8th, and that was not a good thing for a lot of people in Pennsylvania. Yet another example, another one taken from early January this year, but this is just I pulled the NBA standings up at like January 16th or 19th of this year, and you can see right here I could do a lot of different relations. But the way we often talk about relations with sports teams is you might say, hey, how many wins does Philadelphia have? And you'd say, oh, they have 10, right? So the X is the name of the team, and the Y is the number of wins they have. That'd be one way to do it. The other way to do it, and we'll talk about this in terms of functions in a second, is I could say how many teams have 10 wins? How many teams have this, and you'd say, oh, well, there's actually Philadelphia, Miami, Orlando, LA Lakers, San Antonio, and Denver. So there'd be 6 different teams with 10 wins. Those are both relations, but I'm just changing which is the X and which is the Y. You can probably come up with a bunch of other ones just based on this chart. You could talk about who has a winning percentage of 0.714. Or how many teams have 4 loss teams, right? I could go down all of those things. These would all be different relations, and the answer in some cases, the Y value, the answer, our output, would be different things too. So those are relations, but really what we care about the most here is talking about functions. That's what we're going to care about in this class. Now, functions are where we relate. They're a relation, but it's saying that for each element of X, there's exactly one element. That's important because functions are called well-defined. It means that we get an answer for sure whenever we have one of these X's. So let's look at some examples just with numbers in ordered pairs. For this first example, we can see a big problem here. The problem is that our X's are 2, 4, 3, and 2. But we have 2 2's right here that go to different places. Now, this is a 2 going to a 3 and a 2 going to a -1. This means it's related to 3 and related to -1, and if I have a function, I'm saying, well, in some ways, I'm plugging a 2 into my function, and I don't know what it gets out. It's kind of weird. It's sort of like saying, how many wins does Philadelphia have? And saying, oh, it has 5 and it has 6. That doesn't make any sense at all. So that's an example of a relation that is not a function. Now in B, it works, because there's none of those discrepancies or those issues. However, in C, you might see right away that 4 is going to 3 and going to -3. So that is an issue. All right, and that's a no. If we go back to our NBA standings examples, we'll just repeat some of the things we talked about before with our relations, and we'll say if we have the team name and number of wins, that is a function, because I could go over and say, well, there's only one Charlotte team, right? And I know there's some teams that live like more than one in the city, but they're defined like, there's LA Clippers and LA Lakers. So if we go to LA Clippers, they have 8 wins. There's no discrepancy there. There's no ambiguity. They only have 8 wins. There's no way for them to have different types of wins at the same time. That doesn't make sense. So that is a function. But if I go and say, well, tell me, all the teams with 8 wins. Well, there's Portland and there's LA Clippers. and there's Houston. So there'd be three choices. There is ambiguity. There's no specific there's no exactly one answer, and that's what you need from a function. You need to eliminate the ambiguity. You need to be specific. So those are examples of relations that are not functions. And like I said, we're going to mostly talk about functions here. And one of the ways you may have talked about that in high school or in an earlier class would be via a function machine. The reason people talk about function machines is, I mean, it's kind of silly, but it's really because they're saying that what does the machine do? Any sort of process like that, you only, whenever you put stuff into the machine, like if, then you only get one thing out. You can't say like, oh, I might get this out or I might get that out. That's never going to happen in a machine. Machines are designed to produce one thing. Or you press a button, it's like, we're just going to make cornflakes right now. If I'm a cereal maker, right? I'm just going to make one thing at a time. And so functions do that. You put in an x, you take out a y. Now, going forward, we're going to talk about this in terms of domain and range. So that will be part 2.